Does it work? Can you hear me? That's fine. Okay, at least this. I had some slides, but they don't work. So it's going to be a little bit difficult maybe to follow some things, but I hope we'll manage. Okay. Thanks. Yeah, so this talk was about onions and Tor. I'm actually from the Tor project. I work from Tor. And how many of you guys use Tor? That's good. Do you run relays? You should run relays. Maybe you already know what is Tor and what does it do. So there is a little, I wanted to go through that, but I'll go through it more quickly also because I don't have all the network schema and so I will just talk about it. So I wanted to talk how Tor can help you to have privacy and anonymity, and how you can use Tor at the application layer. So the best example is the Tor browser because it packs everything together and is an application that you can use for a very common use case, which is surf the web. And then I wanted to talk about onion services, current onion services and the next generation onion services a little bit, and how you can use Tor within other applications through onion services. So I had a picture of an onion to show it. Who am I? My name is Sylvia. It's on the slides. You can download it later. Some people are kind of confused because they're like, oh, the anonymity people, they present each other with their names. But some of us do, at least. But I think privacy is about choice, right? So if we want to be visible, so you know who builds Tor and who develops and who does other things, we think it's okay to do that. So I work at Tor, I said that. I'm also part of the information security group at UPC Barcelona. Got my PhD there. I don't do much there anymore, but yeah, still part of that. And I'm interested about web tracking and all those things, especially researching what other people share online and so on. Okay. So what is Tor? Tor is a privacy tool to begin with, but it's also like a group of people, diverse group of people. There are researchers, there are developers, there are relay operators, volunteers, people that just advocate for the project. There's a lot of different things. It's an open network, it's a Tor network, and it's a non-profit as well. So there are actually 4 million daily users on Tor. So Tor is also that. And there are 7,000 relays and 3,000 bridges. And 200 gigabyte per second bandwidth advertised and half used. So it means that we have capacity for at least double the users, or well, more or less. So when we want to talk about Tor, the easiest things that we can say is that Tor provides privacy. And that's something that people can relate with, general people. Then we can also say that Tor provides anonymity, which is something that another group of people can relate to. And it also provides communication security for other people. And if we want to be like very specific, we said also that Tor is traffic analysis resistance network. And this is for a very small group of people. But for activists, it's reachability against censorship. So that's important too. It was purple before. It was working, but purple. No, it's not working. Yeah, that's the thing. It's purple.
Yeah. Progress.
Okay. So, how Tor provides privacy. We said that the idea to provide privacy is by design. So we want to build a privacy tool. So the idea behind Tor is to distribute trust. And that is, you don't have to you don't have to trust a single point or a single server or a single cable that cannot be tapped. You just you don't trust no one, not the network, and that's part because the Tor traffic is distributed across the relays. So, okay. So how Tor works. So we have Alice and Bob. They want to talk through the Tor network. Alice is the client, let's say, and the client receives a list of Tor relays that they can reach. And this is received from the directory server. So with this list, Alice picks 3 nodes in the network and reaches Bob. And the traffic across the Tor network is encrypted with the layers. That's the onion, actually, in the onion routing. But when it goes out, it's actually unencrypted. Oh, okay, wait a minute. Okay. So there is actually one thing that sometimes we have to remember is that if you use unsecure protocols on the part of the traffic that goes outside of the Tor network, that part is still visible. So it's still, even if Tor is secure and it's anonymous and so on, it's still important to use secure protocols because there's always a part that goes outside. So we said before that Tor provides anonymity, and anonymity is more than encryption because encryption doesn't protect metadata. It protects the content of the conversation, but not who is talking to who. So your social graph, and there is this great example that I saw in a presentation from the EFF a while ago, and there is this thing that if you call suicide help prevention hotline on Christmas Eve, and nobody knows what you said, but they just know that you called them. Do they really know? Can they already know the content of the conversation? At least they know you have an issue. So that's something to remember about metadata. And also another thing is that encryption doesn't hide your location anyway. So that's also something. But you can also use Tor at the application layer. And we have the example of the Tor browser. And actually, the Tor browser is packaged version modified of Firefox with some other things. It has HTTPS Anywhere, for example. It has NoScript. It has the Tor button, the Tor launcher. In the past, it was called Videlia. And the idea is that you use the Tor browser to surf the web. Here we go. It's page 17. No, it's before that. It's before that. Before. Yeah. A little bit before.
I can give you the remote control.
It's okay. I know I can.
This one down, this one up.
Okay. So. Yeah. Okay. Okay. So you have all these things packed together, and the idea is we want to allow people to use Tor safely with a scope, which is surf the web, and reduce tracking, reduce the possibility to link user activities across different websites. And now we have also the part about onion services and how they provide bidirectional anonymity. So onion services, first of all, are hidden services. We changed the name because bad press, basically. The word hidden was scaring people, and they were giving bad articles about it. So the name was changed. And so we have a 16 characters onion address in base 32. Both the client and the server hide the location. The communication stays inside the Tor network, so there is not this part of that goes outside. And it can be used for TCP traffic. There is no UDP. There are some interesting properties. They're self-authenticated, end-to-end encrypted. Isolation not punching. There is a lot of people that use it just for SSH, for the limit attack surface, and there's censorship resistance as well. This is, I will go quickly how it works. So Bob is an onion services, and what it does, it will pick 3 introduction points that are just relays, basically. And this will be done randomly. And then it will set to the hidden service directory, which is another relay that has been in the network for a longer amount of time. I think it's 96 hours. Hey, this is my descriptor. This is how to reach me. These are the nodes that I picked. And then there is the client that knows that this onion service exists. So it will go, the client will have the address in the browser, in the Tor browser, will go to the hidden service directory and says, hey, give me the descriptor of this onion service. So the way, how does the client knows? It's predictable. I mean, the client can calculate which hidden service directory to ask to. And this is actually a source of issues for a number of attacks that have been on the network. So once the client knows the introduction point, it will make a connection with the onion service, and they will tell the onion service, hey, meet me at the rendezvous point, and they exchange some secrets, and they will just start talking. Because of the way the client knows how to connect to the onion service, there have been a number of attacks. One idea is that because introduction point and directories are just relays, you can run relays with the idea to learn about onion services and just collect them and then crawl them and then index them. Or you can run relays with the idea to be introduction point or rendezvous point and learn who is connecting to hidden services. And these attacks have been mitigated with the next generation onion services. So one thing that they ship is better crypto. I think with onion services, it's 1024, okay. And with and SHA-1, so this has been updated. And then the other thing that we had is that the address line is the actual key of the service. So it's from 16 to 54 characters, which can be an issue, but apparently no one types onion service address. So we are working on that, but still it's good. But the one thing that is actually good is that the new key system allows to create subkeys. So you can use a key maybe for a number of times, and then you can rotate the keys, which is also good. If you don't care about the location of for example, if you're Debian and you want to run an onion service, you can use rendezvous single onion service, in which you have a direct circuit through the rendezvous point. And also because we were making it more difficult to learn onion services and to learn who is connected to onion services by using a system of introduction point that is a little bit more complicated. It's called Vanguards. And also they're adding share randomness in the description ID that also makes it more difficult to predict which hidden services directory is going to have the descriptor, but still can be calculated by the client. So you can use Onion services within other applications, and the idea is that they can be integrated to be more secure. Like if you have a part of your application that you want to run as an Onion service and then also only this connection to it, that can be possible. It's interesting for microservice application or for just running some connection through a database or something through it. And there is actually an example that someone did with the WebSockets that was interesting, and it's about publish subscriber protocol that use Onion services. I got confused. Yeah, that's it. If you have questions, besides it. Sure. The question is about the directory service, how many of them, and how the clients know. There is an algorithm, it is predictable, it's time-based. In the current definition of the Onion services, and basically, at relay that's been on the network for 96 hours can become a directory. So. Yeah, so you can just wait, run relays, and eventually they can become directories. And there is an effort that every day bad relays are disconnected from the network. But we don't say how that is done because we don't want to give attackers this advantage. But the thing that with the upgrade with the next generation Onion services is that there is a consensus mechanism. There is not just something that we invented, it's used also in other applications, and every 12 hours the directory authorities, there are 8 of them now, they share a secret and then they come to a consensus that is changed every 24 hours. And so that goes into the mechanism, and it's a little bit more sophisticated and makes